24-volt monorail track lighting system that is experiencing melting insulation on the secondary wires likely has a few potential causes. Firstly, the number 10 MC cable might be undersized for the current draw. Secondly, there might be an overload on the transformer. Thirdly, a short circuit could exist. Fourthly, the transformer might be faulty. Fifthly, excessive impedance could be present. Let's break down each of these potential causes and how to troubleshoot them. The number 10 MC cable is potentially undersized because with 200 watts of load at 24 volts, the current draw is approximately 8.3 amps. Depending on the length of the run and the ampacity of the wire, number 10 AWG might not be sufficient, especially if there are voltage drop considerations. Secondly, even though the 200 watt load is significantly less than the 1000 volt amps rating of the transformer, the melting insulation suggests that excessive current is flowing, which could be due to a fault, but it is less likely the sole cause if the transformer rating is significantly higher than the load. Thirdly, a short circuit is a very plausible cause. A loose connection, a pinched wire, or another fault within the wiring, track, or lighting fixtures can cause a short circuit. This results in a very high current flow, leading to overheating and melting insulation. Fourthly, a faulty transformer could be the source of the problem. A defective transformer might output a voltage higher than 24 volts, or it might have internal faults causing it to overheat even with a relatively low load. Fifthly, excessive impedance in the wiring can also contribute to the problem. Long wire runs or tight bends can create impedance, which reduces the voltage at the track and increases the current draw, potentially causing the wires to overheat. Now here are some troubleshooting steps to follow. 1. Check the wire sizing. Ensure that the number 10 MC cable is appropriately sized for the actual current draw and length of the run. Consult the National Electrical Code, NEC, Table 310.15. B16 to determine the ampacity of the number 10 AWG wire and consider upgrading to number 8 or number 6 AWG cable if necessary, especially for longer runs, to minimize voltage drop and ensure sufficient current carrying capacity. 2. Reduce the load. Disconnect some of the lights from the track to reduce the total load in the transformer. If the insulation stops melting after reducing the load, it indicates that the original load was too high for the wiring or transformer, or that there is a cumulative effect of multiple small faults. 3. Inspect for short circuits. Carefully check all connections, wires, and track sections for loose connections, pinched wires, or any other potential sources of shorts. Pay close attention to the points where the wires connect to the track and the light fixtures. Use a multimeter to check for continuity between the conductors and the ground. 4. Test the transformer. Isolate the transformer from the track and test its output voltage using a voltmeter. It should output approximately 24 volts plus or minus 10%. If the output voltage is significantly higher or lower, or if the transformer is making unusual noises or emitting a burning smell, it may be faulty and need replacement. 5. Check the impedance. Measure the voltage at the track power feed and compare it to the output voltage of the transformer. A significant voltage drop, more than a few volts, indicates excessive impedance in the wiring. Check for loose connections, corroded terminals, and tight bends in the wires. Ensure that the wire connectors are properly sized and installed. 6. Replace the transformer. If the transformer is determined to be defective or overloaded, replace it with a suitable model that has appropriate power ratings for the track lighting system. Ensure the new transformer is compatible with the dimmer switch and provides the correct voltage and current output. Some additional tips to consider. Firstly, use an appropriate dimmer switch for 24-volt track lighting systems. Standard 120-volt dimmers are not compatible and can cause damage to the transformer or lighting fixtures. Secondly, ensure proper ventilation around the transformer. Transformers generate heat, and inadequate ventilation can cause them to overheat and fail prematurely. Thirdly, consider adding a fuse or circuit breaker to the secondary side of the transformer to protect the system from overloads and short circuits. This can help prevent damage to the wiring, transformer, and lighting fixtures. Also, the initial voltage reading of 27 volts on the secondary side before energizing the track is a bit high. Transformers typically have a tolerance of plus or minus 5%, so a reading of 27 volts is outside this range. This could indicate a problem with the transformer itself, or it could be due to the meter being used for the measurement. When checking for short circuits, use a multimeter to check for continuity between the conductors and ground. Disconnect the power before performing this test. A low resistance reading indicates a short circuit. If the wiring insulation is melting, it is crucial to address the problem promptly to prevent fire hazards and further damage to the electrical system. If you are not comfortable working with electrical wiring, it is best to consult a qualified electrician to inspect and repair the system. When selecting a replacement transformer, ensure that it is rated for at least 20% more than the total load of the track lighting system. This provides a safety margin and prevents the transformer from being overloaded. If the track lighting system is installed in a commercial space, it is essential to comply with all applicable electrical codes and regulations. This may include using specific types of wiring, conduit, and junction boxes. Also, consider using LED lamps in the track lighting system. LED lamps are more energy efficient and generate less heat than traditional halogen lamps, which can help reduce the load on the transformer and wiring. When making electrical connections, use properly sized wire connectors and ensure that they are securely tightened. Loose connections can cause arcing and overheating, which can lead to insulation melting and fire hazards. If the track lighting system includes multiple sections of track, ensure that the track sections are properly aligned and connected. Misaligned track sections can create a short circuit or cause the lighting fixtures to malfunction. Also, regularly inspect the track lighting system for any signs of damage, such as cracked insulation, loose connections, or flickering lights. Address any issues promptly to prevent them from escalating into more serious problems. When working with electrical wiring, always disconnect the power at the circuit breaker before making any connections or performing any maintenance. This helps prevent electric shock and ensures your safety. Consider using a surge protector to protect the track lighting system from voltage spikes and surges. Surges can damage the transformer, lighting fixtures, and other electrical components. Also, if the track lighting system includes a dimmer switch, ensure that the dimmer switch is compatible with the transformer and lighting fixtures. Using an incompatible dimmer switch can cause flickering lights, premature failure of the components, and even fire hazards. Consider using a constant voltage LED driver instead of a traditional transformer. Constant voltage LED drivers provide stable voltage output, which can help extend the life of the LED lamps and improve their performance. Also, if the track lighting system is installed in a damp or wet location, ensure that all electrical components are rated for wet locations. This includes using waterproof junction boxes, conduit fittings, and lighting fixtures. Remember, electrical work can be dangerous, so always take precautions and follow safety guidelines. If you are unsure about any aspect of the track lighting system, it is best to consult a qualified electrician. When selecting wire, make sure to choose the correct type for the application. MC cable is suitable for many applications, but other types of wire, such as THHN or XHHW, may be required in certain situations. Refer to the National Electrical Code for guidance on selecting the appropriate wire type. Always use a torque wrench to tighten electrical connections to the manufacturer's specified torque. Over-tightening or under-tightening connections can lead to loose connections and overheating. Also, when installing track lighting, make sure to follow the manufacturer's instructions carefully. This includes properly spacing the track supports and ensuring that the track is securely mounted to the ceiling. If the track lighting system is controlled by a smart home system, ensure that all components are compatible with the system and that the system is properly configured. Incompatible components or incorrect configurations can lead to malfunctions and even damage to the electrical system. When troubleshooting electrical problems, always start by checking the simplest things first, such as the circuit breaker and the connections. Often, the problem can be resolved by simply resetting a trip breaker or tightening a loose connection. If you suspect a short circuit, use a multimeter to check for continuity between the hot and neutral wires. A low resistance reading indicates a short circuit. To isolate the short circuit, disconnect sections of the wiring or track until the short circuit disappears. The short circuit is located in the last section that was disconnected. Remember that working with electricity can be dangerous, so always take precautions and follow safety guidelines. If you are not comfortable working with electrical wiring, it is best to consult a qualified electrician. If the issue persists after checking all these components, consider the environment the system is in. A humid environment could expedite corrosion and degradation of wire and connections, while enclosed spaces could exacerbate heat build-up, contributing to insulation failure. Also, if the wire run is near sources of heat, such as HVAC ducts or lighting ballasts, this could contribute to the insulation melting problem. In that case, you can reroute the wiring or provide additional insulation to protect it from the heat. Finally, be certain to observe if the insulation melting is localized to one area or occurs throughout the wiring. Localized melting may point to a specific point of failure, while widespread melting might suggest a more systemic issue such as an overall overload or a faulty transformer. Remember, safety should be the utmost priority when dealing with electrical systems. If you are uncertain at any point, seek the assistance of a certified professional. Their expertise can ensure the track lighting system is not only functioning correctly but also poses no risk to the safety of the occupants and the building itself.